Yes, guys. Hello, everyone, and welcome to the second session of a subject called a formal language and automatic theory. Guys, okay. Simple. Last class, let me brush up the thing what we have been discussing in the previous class. And I hope, like last class, I just said why we want to read or why we want to study a subject called an automata theory and its computation. And I just gave few examples regarding that. Let me go further towards it. And now let me tell about like introduction about a formal language. Okay, whenever I say a formal language, an automata theory, and everyone comes under a formal language and automata theory. And let me tell about an introduction about formal language. Yes, today's class is a major class because from now on, I'm not commenting on only on today's class. From now on, we guys will keep on going towards many definitions and many new words we'll be listening to it. And I request like you guys let get used to those different kinds of words and let's start the things. Okay, first and foremost, whenever I want to tell about something called introduction about a formal language, first word which I want to tell you about, the first thing is there's something called as a language. There's something called as a language in a automata. Okay, what do you mean by language in automata? I'll explain that everything in detail. And the next thing what we learn is called something called a grammar. Something called a grammar. Yes, even the same thing, what is a grammar and everything will be explained later. And at last, we'll be learning something called as machines. And we'll be learning something called as machines. Machines. There are different kinds of machine in a given subject called an automata theory. And few things what we'll be studying is, as I've already been explained, is one is a finite automata. And next one, I hope you guys can guess it. And next one is something called as push down automata. And next one, I hope you guys can recall this again, which I have been explaining in a previous class. That's called as a Turing machine. Something called as a Turing machine. And with this regard, there are many other machines what we'll be learning in the given subject. And let me focus only on this thing in a given subject called as a formal language and automata theory. Okay, now let me come up with what exactly you mean by something called as a language. What exactly you mean by something called as a language? Now you guys can ask me a question like, sir, is this a language called Kannada language, or is this a language called in Hindi? Is this a language called English? Yes, this language depends on a system to a system. This language depends on a system to a system. And currently, whenever we give it with respect to any machine, for any machine, there will be a language. For example, last class I've been explained there's something called as NLP, neural language processing. Means natural language processing. I've been explaining about NLP. What is the example of NLP? I've been said something called Alexa, where there is a language called English. I speak something called English to Alexa, and it bounds me back a result, and that's called a language. Now I'm explaining a language with respect to a automata or a formal language. Okay. Whenever I tell about a language, let me take up an example, and then I think I can explain it. I will just take a language called English. I'll just take a language called in English. English only, there are few other parts where we discussed it. In English, there are few parts. I'll just take an example called in English. In English, there are few parts, and that part, I say something called, there's something called alphabet. There's something called as alphabet. What do you mean by alphabet? Same old thing, guys. Alphabet's meant to say it's A, B, C, D to Z. It's called an alphabet, right? And next, and the same way in English, there's something called as word. There's something called words. What do you mean by word? City is a word, engineering is a word, college is a word. Same old thing. And next thing, there's something called sentences. There's something called as sentences. Sentence, you know, city, engineering, college is one big sentence. Clear? And next thing, there's something called as a grammar. There's something called as grammar. What do you mean by grammar? There are many clauses like a word city is a grammar. For example, many other things comes under a grammar. The given sentence says good, says wrong, plural, noun, pronoun, many other things with respect to something called English as a language. Now, when I come across an automata theory, when this was a normal general example which I gave explanation. Now let me explain the same thing with respect to automata. Okay, let me explain the same thing with respect to an automata. Okay, now what exactly you mean by an automata? And sir, everything comes under automata? Yes, guys, everything comes under a same thing called an automata. In an automata, there are alphabets. In automata, there are alphabets. Sir, what do you mean by alphabets? Here in English, we said alphabets are A, B, C, D, E, F, G, or A to Z, capital A or small a. Only this thing we can represent as an alphabets in an English. But with respect to an automata, we say each and everything as an alphabet. For example, A to Z or uppercase A to Z or 0 to 100, I'm going to say 0 to 9, any numeric value, each and everything we represent as an automata. Here in automata, whenever I say an alphabet, in English the alphabets are only A to Z. But when I am telling an alphabet with respect to automata, it is an entire alphabet letters where it comes from A to Z, lowercase and uppercase followed with a numeric. Each and everything will be there. The main thing is the alphabets are being denoted in automata as a sigma. The alphabets in automata, it's been denoted as a sigma. Okay, now let me talk about word and sentences. Yes, there is a word and sentences in alphabets, in automata also. But we call word and sentences as a string. We call both as a string. Here in English there is a different thing. A word, single word, city is a single word, engineering is a single word. But in English we call everything together called a sentence. But when I am telling with respect to an automata, words is there, sentence is there. We call word and sentences as something called a string. What is a string? A combination of few letters is called as a string. Simple definition: a combination of few letters is called as a string. For example, I write AA is a string, and I write BB is a string. I write 01 is a string. Whatever I write a letter, whatever I write a word, is a string form, because whatever string I write, it has to match with respect to my machine. That machine which tells me what word I have to write. Clear, guys? Okay, this is what about here. If you observe here, I have been specified something with respect to a lower case. I have been given example with respect to a higher case, upper case, and with respect to a numeric also. Is that clear? Okay, this is what you mean when meant to say by a strings or a word in a sentence in a automata. Clear? Okay, let me come with a last one, something called as a grammar. Yes, guys. Even here, I mean to say, even in an automata, there is something called as a grammar. In this grammar, as I've been saying you, it's a separate topic. It's a separate topic. I will explain you a grammar. For example, I will tell you one thing. Okay, I'll just take an example of an English one. Then I can explain you what exactly a grammar is and how exactly a grammar works. For example, okay, this is all about automata. Even in automata, there's something called alphabets. Alphabets is represented as a sigma. How many alphabets it can be there? It can be lowercase, uppercase, and a numeric. This all alphabet. And there is something called a string. What do you mean a string? A combination of n number of words. It might be length 2, it might be length 3, it might be length 4. It's called as a string. Okay. And next something called as a grammar. Grammar, like whenever I write something called as an automata, it has to hold good for a grammar. Whenever I write something for an automata, it has to hold good for a grammar. This grammar here has some clause, and that clause will be given specified in a later version. Okay. Now let me write an example, guys. Let me write an example. What exactly you mean by a grammar? What do you mean by a string? What do you mean by alphabet? I'm giving an example with respect to English. I'm giving an example with respect to English as a language. Clear? Okay. Here by example, look. Simple thing, guys. I make use of sigma. What do you mean by sigma? Sigma meant to say sigma is a alphabet. Sigma is an alphabet. In English, sigma is an alphabet. What are alphabets I can use? Either I can use a lowercase a to z or uppercase a to z. So here I write a sigma. What are the letters I want? I need A, B, C, and D. I write something called A, B, C, and D. So now I have to write words or sentences. Now I have to write words or sentences. So how to write a words or sentences? Simple thing. Now I give a restrictions. I give a restrictions. This is what is called a grammar giving a restriction. Now I give a restriction. The length of a given word should be 3. The length of a given word should be 3. And here the length is been denoted as 2 pi. The length is been denoted as 2 pi. For example, W stands for a word. W stands for word. If I write a length of a W is equal to 3, so what I will take? I will take the set of symbols or set of alphabets with a combination of 3 letters. Okay. Now this I will write length of a word as 3. Let me write the things. Okay. Now I write length of W should be is equal to 3. Now let me write. Inga 3 baredu. Okay. Here L stands for a language. L stands for language. Now I am writing a language with respect to English. L stands for 3-letter word. How to write a 3-letter word? It is simple. I have 4 alphabets. Out of this, I write 3 words. Okay, first let me write A. Don't you guys feel it's a 3-letter word? Now simple. Probabilities. Hope you guys know what I mean probabilities. I'll be writing the probabilities of the given alphabets. I'll be writing the probabilities of a given alphabets. For example, A. Next one. Can you guys come again with me? A, ABA, ACA, ADA. Agadala? Can't you guys write it? Good. Same old thing. Next. Yep. BBB, BAB, BCB, BDB. Correct? Same old thing I keep on writing. How many combinations I get? I get n number of combinations. Out of this, there are few more letters also which comes here. For example, can't I write DAD? Can't I write DAD? Can't I write BAD? Each and everything comes under a given language. DAD, BAD, CAD. Okay, for example, I write CAD and some other thing. Now you guys have to make a note. What exactly a note says that I have written a language where the length of the given language is 3 by making use of an alphabet A, B, C, D to form English. Out of this, if you observe the thing properly, only these 2 words are with respect to an English form. Only these 2 words are with respect to a English form. Remaining all are a crap. I won't say remaining all words are available. Here I give a restriction saying like if DAD comes, it's in English. Other one is not in English. Here, if DAD dad and dad comes, it's in English, or else I never represent this as my English word. Clear? This is what we call as a restriction. For example, I give you an example. As I've been saying you, all of a sudden I just called to Alexa. Alexa, can you play Dinkanaka song? Some random again, don't mind. Alexa, can you play Dinkanaka song? Can Alexa understand the language? No. But for me, okay, Dinkanaka, there is a song by name that, but Alexa is not able to understand. But for Alexa, Dinkanaka is this kind of sentences or a word. So it doesn't understand. What does Alexa do? It throw me back. Sorry, dude, I'm not able to understand your language. Can you come back to me? So I say in a different way. Dinkanaka, the standing stage of the language, I'll tell. Okay, this all a meaning of a given thing. Are you guys clear? Okay, let me come up with this just an introduction. Now I'll be playing with respect to languages. I'll write few example and then explain. Okay, let me explain. Let me redo it each and everything again. Whenever I say an introduction about a formal language and automata theory, or another word an ATC, automata theory and its computation, here are a few things where we will be learning in a given subject. For example, we will be learning something called as a language in an automata. A stands for automata, I'm sorry. There's something called as a language in a automata, and next one is there's something called as a grammar. Grammar I will explain it later. There's something called as a grammar in automata, and there are few machine explains in a given automata, and the machines are finite state automata or a finite automata, push down automata, and a Turing machines. This is all about this. And let me come up to the language. What do you mean by language and what exactly you mean by language? In a language, there are three major things what we will come up with this. One is there's something called a set of alphabets, and next one is something called a word or a sentence, and next one something called as a grammar restrictions. Clear? And with respect to English as a language, we can bifurcate the given thing as alphabets, words, sentence, and a grammar. When I take something with respect to automata as an example, when I take with respect to automata as an example, here there is something called as alphabets, there's something called as a string, something called as a grammar. Okay, alphabets in there. What all alphabets can be there in a given automata? Lowercase a to z, uppercase a to z, and 0 to n. I'm going to say the numeric number, and this is represented as a sigma. And when you come to a string, what is a string? It's a combination of two letters. A combination can be anything, AA or AB, BA or BB. This is a combination of the symbols specified, and something called as a grammar, which I'll be explaining in detail later. Okay, now if I start explaining, I think it might be a bigger version for you. So let me skip the grammar for a while now, and I'll just take an example and I will explain what you mean by a proper automata as an example. I hope you guys are clear about this. Okay. Meanwhile, let me take an example of an automata and then explain. Okay guys, I request everyone to make use of a pen and a paper now. Whatever I be explaining, I want you guys to make a note of this. Don't think more. Whatever I write, try to make use of pen and paper and just scribble it. After end of the class, you guys will learn something. If you keep on listening, I hope like it will be difficult for you. Make use of pen and paper for a while, please. Start. Okay, let me explain you with respect to exam point of view. In exam point of view, they'll be asking a given question, like simple thing. So, okay, in exam, is this a question comes? Yes. They'll ask you, what do you mean by a language? They'll ask, what do you mean by alphabets? They'll ask, what do you mean by string or a word? Both mean the same. Keep up things. String or a word. They'll ask. So each and everything they'll be asking for it, and these are the questions they'll be asking in the exam. Okay, what type of question? How exactly a question? Frames of. Okay, let me take an example of it. Now, for entire set of few questions, I'll be using sigma as x and y. Now, you guys have to tell me, what do you mean by sigma x y? Sir, yes, sir, like is that sigma x and y? I'm making confusion for you, or you making panic for me? Simple, like I've been explained now. What do you mean by sigma? Sigma is a set of alphabets. Perfect. And what are the alphabet I am using? Now I am using x and y. Earlier I used something called as A and B. And for the given example, previously I used as A, B, C, D. So now I have to write something by making use of a letters called x and y. Clear? Okay, let me write my first ever question. And my first question says, there's something called L. What is this L? L stands for language. There's something called L. L says set of all string where length is equals to 2. Where length is equals to 2. Clear? This is a given question. Okay. The given question says for me, I have to write a language as I have been saying, the language which contains set of words. Okay, the language which contains set of words. I have to write a language where the set of all strings, string means a 2-letter word, 3-letter word, 4-letter word I have written there. It's called one string. Where a set of all strings length is equals to 2. Now here there is a question. So what do you mean by is equals to 2? It should be exactly equals to, or it can be less than equal to, or greater than 2. Now, whenever they use something called is equals to, it should be exactly is equals to 2. Clear, guys? Okay. Ivaga, what I have to do? Let me write a solution. Now, okay, I write a solution for the given language where the language I will be writing a set of words. And what is the words? Ivaga, I have to make use of only these 2 letters X and Y. I have to make use of only 2 letters X and Y, and such that the length of X and Y should be exactly 2. The length of X and Y should be exactly 2. In order to now, let me write. I'll write a probabilities of this. So, can I write like this? XX. Does the length of this is 2? Correct? And next one. Perfect. Can I write this as XY? And perfect. This is YY and YX. Clear? This is a solution for the given language. And this is a constraint specified. For every language, there will be a symbol. For the given symbol, there will be a constraint. I have to write a solution of it. It's a simple thing. These questions carry minimum 3 marks, guys. Minimum 3 marks. Easy go. Okay? One thing we have to learn, listen. There will be a language. For the given language, there will be a set of symbols used. For the given symbol, there will be a restrictions or a constraint or a condition. For the given condition, I have to frame a words. Okay, now you guys can ask me a question. Sir, do XY and YX both are same? No. Both are different. Clear? XY and YX, like the given word of this is different, the given word says a difference. Clear, guys? Now, for the given question 1, the solution is this. Is that clear, guys? Okay, let me explain few more examples. I hope like you guys can come to with it. Okay, let me write the second one. Here, I will make use of a symbol X and Y only. Now I write the language L where set of all string where the word W 2 pipeline. W 2 pipeline. Yes, it's called a length. The set of all string where the word length should be less than or equal to 2. Should be less than or equal to 2. Okay, now let me come up with the things. The given question. I always, whenever a given question says, you have to think 3 things in mind. I have to write a language with respect to a symbol to hold someone a satisfaction for the given constraints. How to write? Simple thing. Less than equal to 2 andre, no? Simple. 2 comes, the length of 2 comes, the length of 1 comes, and the length of 0 also comes. Okay, for this, I hope you guys understand this. Okay, let me write a solution for this. And the solution for this, a language L, I write set of words. Okay, less than or equal to 200, 0 is also there. Can I write 0 like this? No, I can't write 0. If I write 0, 0 is being considered as a alphabet or a symbol. So and hence I can never write 0. So instead of 0, I make use something called as an epsilon. I'm making use of something called epsilon. What do you mean by an epsilon? There's something called epsilon. Epsilon means there's nothing. There's nothing. Just a. push. Epsilon andre nothing. See, for example, if I write 0 over here, 0 is an alphabet for a given symbol, but 0 is not specified, so I can never write 0. Correct? Or if I use null, null is a symbol, so where I can never use. For this regards, there is a new symbol called epsilon. What do you mean epsilon? Epsilon meant to say nothing or just a push. Is that clear? Okay, now epsilon meant to say 0. Yeah, sir, 0 is being done. Lovely. What next? 1. The length of string is 1. How to write 1? Making use of x and y. Simple. X. Don't you feel x is 1? Perfect. Can I write y? Yes. X is very good. Y. I have written x and I have written y. The next is simple. Sir, 1, 0 over 1, 1 over. The next one is the length of 2. How to write 2? xx, xy, yx, yy. And this is the solution for the given. Is that clear? I hope it's been clear for you. Okay. Let me give few more examples. Okay. Now I'll be explaining about 6 to 7 example and we'll wind up the class. And I'll write a question. I'll be giving a minute time. I want you guys to think and you write a solution, and meanwhile even I will start writing a solution. Okay. Let me go with the third question. I'll be using same symbol x and y. I write a given language where the given language is set of all strings having an even length. Set of all string having even length. Okay, a time given for you. You guys can think, start thinking and writing. Meanwhile, I'll be explaining few things. Okay. What do you mean even length? Even length meant to see? It's a combination words of 0, 2, 4, 6 and so on. A word where the length of the word should be 0, the length of a word should be 1, the length of the word should be 6 and the length of the word should be 4. This is called even. Shall I? Done. Okay. Here I write a solution where a language L. Okay, first let me write a solution for 0. What is it for a 0? How can I write for 0? Can you tell me? 0 means perfect. Epsilon. Okay, now I have to write for next letter is 2. How to write for 2? How to write for 2? Don't you feel these are a length of 2? So I write here as xx, xy, yx and yy. The next is length of 4. How to write the 4 letters? How to write the 4 letters? If I give a probabilities of x and y, 4 letter words will look like xxxx, xxxy and so on. Is that clear, guys? Is that clear? This is all about the given even. Is that clear? Okay. Now let me go with one more question. Okay, I'll be going with the next question. Where a language L is a set of all string. Now let me make use of different words. Okay, here a language L containing a word where the length of a word mod 2, the length of a word mod 2 contradict to 0 mod 2. Here goes the question. I repeat here again. There is a language L where a word such that a length of word mod 2 is equal to quadrature ಅಂದ್ರೆ it's saying this is equals to 0 mod 2. A length of word mod 2 is equals to 0 mod 2. This is a given question. Think for a while and do it. Okay, now let me explain. Length of mod 2 means length of mod 2 means length of mod 2, okay, is equals to 0 mod 2. I'm getting confused. Correct? What do you mean by to say? Simple. I'll take a number called 1. I'll take a number called 1. I divide it by 2. Zeros are, and it is 0. Remainder is 1. 0 mod 2 meant to say I take a letter 2 and I divide it by 2. If the remainder is 0, then this word is said to be a mod 2 word. Is that clear, guys? Simple. Okay, next let me take an example called 4. 2 is 4 and 0. Perfect. And 4 is a mod 2. Let me take 5. 2, 4, 1. I got a remainder as 1. Is this 1 0 mod 2? Illa. 1 is not a 0 mod 2. And hence, the given solution for this is it should be in the combination of 0, 2, 4, 6 and so on. And what is the language for this? Same example. Is that clear, guys? A given questions can be asked in any way, any different way. The thing is, like, we should be more strong about like the terminologies and what we are using on. Simple. I repeat this again. The length mod 2, the word mod 2 should be equal. It's called a quantitative condiment. It's the same. Should be equal to 0 mod 2. And whenever I take the things, the remainder should be a 0. I take a length called 0. Remainder is 0. Lovely. I take a length called 1. Remainder is 1. It's out of it. Now I take a length called 2. Yes, remainder is 0. I end it. Now I take a length called 3. No, it's gone. 4. Yes, the remainder is 0. 5. The remainder is 1. So again it's gone. So this way we do it. And the letters will be 0, 2, 4, 6, 8. A solution for this. Is that clear? Okay, let me take few more examples for making use of my practice. Let me take few more examples. Now, let me change a symbol. Yes, I will change a symbol. Which symbol shall I use for a while now? Alphabets are right. Let me go with the numerics. Lovely. I will make use of a symbol called 0 and 1. Yeah, that means say from now on, whatever the answer I write here, the symbols are with reference to zeros and ones. Clear? The symbols are with respect to a zero symbol. Okay, let me write a first language where the language set of all string with odd length. Set of all string with the odd length. Now again, 1 minute given for you, the 30 seconds given for you. Think and write. Should you want to explain this? I feel like no for it, and I hope like my guys are pretty well. Good. Keep up. Okay. Odd length and the odd length meant to say it starts with 1, 3, 5, 7. It's called as an odd length. Now let me write a solution, and the solution I'm sorry. The language. Okay, I'm writing the solution. Where the solution, a language L. First, let me satisfy 1. Length should be 1. Which are the symbols I am using? Zeros and 1, not A and B, guys. X, Y, Allah. I will change to zeros and 1. Now the length should be 0, 1. Okay, now don't get confused. Sir, 1 no same. No. This is just symbols. Clear? This is just a symbol. This is just a length. Both are two different things. Clear? Okay. And 0 and 1. Lovely. Next one is 3. 3 means? Yeah, perfect. 0, 0, 0. Correct? 0, 0, 1. Correct? And 1, 1, 0, 1, 1, 1. I hope you guys are clear about this. Yes, guys? Done? Okay, now let me go with the next question. Let me go with the next question. Where a language the word where a language has a word where the length of W mod 2 is equal to 1 mod 2. The length of W mod 2 is equal to 1 mod 2. I feel like our students have been smarty now. So here are smarty and yes, okay. I'll take a number, I will divide it by 2. The output should be okay, contradictory. The output should be such a way like the remainder should be 1. And I take an example as 3. I'll divide with 2. 1s are 2, remainder is 1. Yes, now I take 3 as n. Let me take 4 as n. 4 divided with 2. If I take 2, 2 2s are 4 and 0. Can I take 4 as n? No. Now I'll take 5. 2 2s are 4 1. Yes, 5 in. Is that clear? So don't you feel like the answer is? Don't you feel like the answer is lovely? 1 3 5 7 and so on. And yet again, don't you feel the solution is the same of an odd length? Yes or no? Clear? Okay, now, yeah. The same way there are a same thing. Okay, let me take one more example where a length L. Let me take one more example where a length L. Okay. Okay. Where a language L, it's a word where such that a length of a word mod 3 contradicts to 0 mod 3. The length of a word mod 3 contradicts to 0 mod 3. Just again guys, 30 seconds for you guys to think for a while, and now I want to answer for this. I explain this again slowly. A language L using a symbol 0s and 1. The constraints are the length of W mod 3 ಮಾಡಿದಾಗ means when I'm dividing the word by 3, my output should be 0 mod 3. Is that clear? Is that clear? Yes. Think for a while. Shall I write? Okay. This question can be asked in another way also. A language L where the length of a word is divisible by 3. The length of the word divisible by 3. If you think properly, if I divide anything by 3, the remainder should be 0. For example, if I take 2, if I divide 2 by 2, the remainder is 2. If I take 3, if I divide 3 by 3, the remainder is 0. Perfect. I will write here as 3. Okay, if I take 4, the remainder will be 1. If I take 5, the remainder will be 2. If I take 6, the remainder will be, I'm sorry, 6, the remainder will be 3. If I take 7, remainder will be 1. If I take 8, the remainder will be 2. If I take 9, it again the remainder will be 3. So it's a combination of 3, 6, 9, 12 and so on. Correct? Adike, the given question can be in this way, or the given question can be in a divisible by 3 form. Clear? Okay, let me write a solution for this. Okay, the solution for this is, here I write a language where the results of a languages are one thing other messed up 0 3. Correct? Anything 0 3 means it's 0 3. 0 on the epsilon, the length should be 3. 3 means 0 0 0 0 0 1 1 1 0 1 1 1 and so on. Next 6 means 0 0 0 0 0 0 6 letter. Come on, 0 0 0 1 1 1 and so on. It can be n. It can be. Yeah. Is that clear? Okay. Now next question I will not solve. I want you guys to do it on your own. Okay. Here a language L where the language L contain a word such that the length of a word mod 3 is quantity 2. Okay. 2 mod 3. 2 mod 3. Okay. I'll explain this. I know it might be difficult for you. There will be a word where the length of a word mod 3, if I divide the word by 3, the remainder should be 2 mod 3. Anything I divide, the remainder should be 2. Anything I divide by 3, the remainder should be 2. So, can you guys tell me? Okay. Think. I want you guys to answer this. Clear? Think. I want you guys to answer this. Okay. Now, let me go with next one. Okay. Let me go with the next and the last one. Here I write L. Here I write L, where the language L. Okay, here I write L, where the word such that NA of W. NA of W. What is NA of W? NA of W means to say number of A's in a word. Number of A's in a word. Oh, for example, now I've been taken zeros and one. Number of zeros. Zero confused. Let me take one. Number of ones in a word. The length of number of ones in a word mod 2 is connected to a number of 0 mod 2. Clear? Mod 2 is a 0 mod 2. So here, what are the given question says? The given question says that number of ones in a given word. Number of ones in a given word. Number of ones in a given word. Mod 2, the remainder should be 0. Clear? Andre, don't you feel like it's this length? I will write this indirectly as the A's present should be 0, 1, 2, sorry. The number of A's present should be 0, 2, 4, 6, 8 and so on. The A's present. And one the word only. Whenever I take any word, the number of A's should be present with the length of 0, 1, so 0, 2, 4. Okay, sir. Confusing. Simple. Let me write a solution N. 0 meant to say first letter 0. Lovely epsilon. This is the easy one for me. I can do it. And number of A should be 0. Number of A should be 0. Can I write only B? Can I write only B? Very good. A is 0. Correct? Okay. Can I write 2B? Can I write 2B? Yes. Very good. Because A's are 0. For me, first constraint for me to satisfy is number of A's should be 0. Yes, I can write 2B. Then can I write 3B? A's are 0. 4B, 5B, and so on. Yes. N number of B's because A's are 0. Now let me come up with the next constraint 2. Number of A's is 2. So number of A's 2. I write a word, a length of 3. I write a word where some length, there should be 2 A's. There should be 2 A's. So 2 A's meant to say AA. Correct? Perfect. BAA. 2 A's, 1B. Then ABA. 2B. 2 A's, 1B. Perfect. Then AAB. Correct? AB. I know. Now let me go with the 4 words. Okay, again this one. Can I write BBAA? Yes. Can I write ABB? Yes. And so on. I hope you guys are clear about this. Clear? Simple thing, whenever you come to know about any language and its constraint, we have to think and we have to write. That's it. Okay. And here arbitrary of A and B's, and the answer for this should be with respect to ones. Clear? I've been done a change, and what's that change? Illy arbitrary as epsilon BBB. I have to write something with respect to using a symbol 0 and 1. So what I have been used a symbol A and B. Clear? So instead of this epsilon 0 0 0 0 0 0 0 0 0 0 0, then go with this. Is that clear, guys? Yep. Okay. Let me brush out things again. Okay. This is how the questions look like in a given exam. And in a given exam, they'll ask you a question in this format. Write a given language for the given word by using a symbol epsilon, x, and y. L is the language. A language set of all string length is equal to 2. I will write all string length is equal to length less than 2, 0, 1, 2, 2, 2. Clear? And 3 and 4. And these are the quite examples for a given thing. And any queries, you guys can think on it. Is that clear, guys? Any queries?